I haven't checked yet. She just told me to wait. Okay, cool. Okay. Hi, everyone. So SafeSol, right? I hope everyone here knows that like writing secure code in Solidity is pretty hard. Like, well, it's been proved that there's been like a ton of mistakes, like the DAO and the party wallet and all that stuff like that. Well, that's been proven. Now, for this, there are a couple solutions, and everyone knows them. They're like getting a good test suite for your contract, using formal methods of verification, properly understanding Solidity, and knowing how your contract works and all that. But the thing is, like, while all these solutions, they work well, and everyone knows them and all that, they're not solutions for people that just got started with Solidity. So for some people, well, some guys who just like read a 20-minute Medium post on how to create a decentralized Twitter, or they just like went through some chapters of Crypto Zombies, these are not proper solutions because they require a large time investment, or, well, they're out of work and essentially they're not viable. So there's a gap there of a solution that can help people that are just like new to Solidity make safe contracts without requiring a large investment. And that's where SafeSol comes in. So SafeSol was born from me trying to teach Solidity to other people and seeing them fall in the same pitfalls again and again. And so I created this. And SafeSol essentially is a drop-in replacement for Solidity. What that means is that essentially you can have like your Solidity code, and instead of like compiling it with Solidity, you just like compile it with SafeSol. So it's just a normal compiler that essentially works the same way as Solidity. But it outputs, well, the output tries to fix many pitfalls that are pretty common in smart contracts, by essentially using safe defaults or, well, making some decisions that have trade-offs for you. So you may be wondering, whoa, if like such a thing exists that it just like magically fixes your contracts and makes all your contracts secure, like this miraculous thing that fixes everything, why isn't that already part of Solidity? Why isn't everyone using it already? Like, well, the thing is that to make these safety guarantees and to like avoid these pitfalls, essentially Solidity makes several trade-offs that, because of them, the features in Solidity shouldn't be included in, well, features in SafeSol, sorry, shouldn't be included in Solidity, or everyone doesn't have to use them. So to explain that better, let me look at the case of SafeMath. So for those of you who don't know what SafeMath is, essentially a library for Solidity that provides security for, well, or provides guarantees for the case of overflows or underflows. So if some variable in your code overflows or underflows, it just like reverse the whole state. So that's pretty good because, you know, in other languages, people don't really think about what will happen if there's like an overflow and underflow. And then they come to Solidity, they don't think about that either, and they create contracts that have vulnerabilities in them, because then there comes an attacker, triggers one of these overflow or underflow, and you have like essentially undefined state, and bad things happen. So it's pretty good for that, but the issue is that it can also introduce vulnerabilities in itself. So for example, someone might go and get some variable in your contract to a very high number, and that means that if everyone, like anybody else, tries to make some operation that increases the number, it's going to trigger an overflow, and the whole thing is reverted. So essentially, you got yourself a contract that's bricked. You can do anything with it. Nobody can do any operation with it because it's like the whole thing is always reverted. And well, that's pretty bad, right? Because you had a contract that didn't have any vulnerability before. You added SafeSol, thinking, oh, I'm going to solve some stuff. Essentially, now you have like a contract that's vulnerable. So the thing with SafeSol is that while it's better than just not thinking about underflows or underflows, well, overflows or underflows, if you're an expert programmer or in Solidity, you can like think about these cases and craft specialized edge cases for these. So for example, if in your contract you can handle like in one part of the contract the overflows in some way, another part of the contract can handle the overflows in some other way, and eventually you can craft a solution that's way better than SafeMath. So essentially the idea is that SafeMath is better than just not thinking about those edge cases, but it's worse than actually crafting special edge cases for these things. So if SafeMath was to be included in Solidity, essentially you would be taking away out of control from smart contract developers, and well, that would be bad, because that's not what Solidity is for. So yeah, some stuff doesn't belong in Solidity. Some stuff that can help people that just got started isn't well suited for being included in Solidity or being used by everyone else, because, well, everyone, because it can take control away, and, well, it's just like not meant for everyone to use. So yeah, the way I like to conceptualize the idea of SafeMath is that if SafeMath is like training wheels for underflows or underflows, so the idea is that like you start using SafeMath because it's easy, doesn't require a large investment, and makes your contract secure. Eventually, you should be, when you're like crafting like real contracts, or like contracts that are gonna hold like a lot of money and stuff, you shouldn't use SafeMath. You should like craft think about the edge cases of underflows or overflows, and like do the checks yourself and apply a specialized rule that work better for your contract and all that stuff. So yeah. So I've been talking about what SafeSol is. Essentially, compiler that makes some trade-offs to help people that are new to the language not fall in many pitfalls of it. But let me talk about what SafeSol is not. So if it hasn't been clear already, it's not a replacement for Solidity. It is not in direct competition with Solidity. It's essentially just like SafeSol targets a special part of the Solidity developers, like those that just got started or they don't know many of the pitfalls or many of the subtleties of Solidity, and for them it's better because it essentially just like avoids these pitfalls. But eventually the idea is to start using SafeSol because of this, but transition to using Solidity because that allows you better control. So essentially at some point, users of SafeSol should learn Solidity properly and transition to the real thing, you could call it, I guess. And yeah, the other thing is it's no silver bullet for Solidity, for security. Using SafeSol to compile your contracts is not going to make them automatically secure or like do anything. It just like avoids some pitfalls and does some trade-offs that are like, well, you may argue they are better or worse, but yeah. So I've been talking a lot about the idea of the concept of SafeSol and why was it born and all that, but what is actually inside SafeSol and what happens when you compile it with SafeSol instead of Solidity? Well, one of the features of SafeSol, it has essentially built-in SafeMath, right? So just like code and like do normal sums using the sum operator and all that stuff. And that includes overflow or underflow security. So essentially it just like reverts whenever there's like an overflow or underflow. So you just like write all your operations normally and bam, you get SafeMath for free. Unsigned and, well, unsigned integers and signed integers, which is important because currently the OpenZeppelin library is only for unsigned integers. They have like this signed thing, well, library for signed integers, but they put it back into draft mode a few months ago. So yeah, well, SafeSol includes support for both. Now, next, checks on external function calls. So what I've been seeing when I'm trying to like teach people Solidity is that plenty of times people don't think about that. And the thing is that sometimes if you make an external function call and somebody has already modified, well, the contract calling you has modified the call stack and reaches, I think it's 1024. Essentially, that call, that external function call can fail, but you won't get an exception, so the whole state of the contract won't be reverted. You just get like a return value of fail or false. And well, people essentially don't check those, and that can lead to a lot of vulnerabilities. So for example, if you have like some contract sending CryptoKitties, a contract that, if that contract doesn't check if, well, if there's like the return value and all that, we can get to the case that the contract thinks he has like sent a CryptoKitty, and its internal state reflects that it doesn't have that CryptoKitty anymore, but because the external call has failed, he actually hasn't sent the CryptoKitty. So you have like mismatch between like the internal state and the real state. So that you have like, well, that's a vulnerability essentially. So big issue. So what SafeSol does, it just like includes automatic checks on every function call. And if something bad happens like that, like there's failure on the external call or whatever, it just like reverts the whole contract state. So pretty much like SafeMath, but for external function calls. Now, next. All right, that's a big one. Well, so another thing that I've realized a lot of people miss is that they usually craft a contract, they look at they might have like only a single payable function, and they say, all right, so I can only get paid through this function, or like money only has like this single point of entry into my contract. And they might even have like written, well, I don't remember the name, but the function that like allows you to, well, that is getting called when you receive a payment. And they might have like written this function so that every payment, but like some accepted by them, is reverted. So they get to the, well, they think that essentially they can control totally the flow of money coming into their contract. So they know exactly how much money is going to be at each stage of their contract or like at each point. And that leads to them writing code where essentially they have like strict equality checks on balance. So for example, if balance or required balance is exactly equal to 1 Ether or whatever. Now the issues with that is that some attacker may just send like one way or whatever amount using the self-destruct function. And then you have like all these equality checks are wrong because your contract has like just a tiny bit more than what is actually expecting. So, bam, your whole contract is bricked or breaks or whatever. Now, that's pretty easy to fix. It's just like you just have to consider the assumption that you can control the flow of money into your contract to be false and transform all these equality checks into greater or equal checks. And that just fixes it. As far as I'm aware, and I have looked into it, there's no downside for that, so it's kind of like perfect fix. Now, yeah, that's like the total opposite of that. It's not a perfect fix. So I decided to include that as part of SafeSol because consensus in its guide around like contract security and all that says that that's already been, well, there's been a lot of misuse going with TX.ORIGIN because people come into Solidity think that, oh, all right, I can use that for authentication of my contract. So like the typical, if TX.ORIGIN is equal to owner, then allow any changes on the contract or something like that. And well, that leads to a lot of issues like a contract redirecting flow from that contract to the contract that checks on TX.ORIGIN and being able to like impersonate the owner of the contract. So they have like admin control of the whole contract, and well, that's pretty bad, essentially a vulnerability. And well, an easy way to fix that is essentially like transform TX.ORIGIN for message sender, which essentially is like the proper way of doing authentication. So the thing about this is like I'm quite on the fence about this feature. Currently it's implemented, but I'll probably take it away in a few or like next release, depending on the feedback I get on it, because essentially it can lead to some issues with programmers. For example, reading the documentation and finding out like what TX.ORIGIN is, and then like getting some unexpected results because we're actually transforming to message sender. So it has like some real drawbacks, and actually in the wild, I haven't seen people using like making this mistake. So I don't know how real it is. Like currently, it's in because consensus thinks it's a really important vulnerability, but probably in the future, well, depending on how if people like it or not, we might take it away. So next thing, reentrancy. So in the first versions of SafeSol, I created a new function, like, well, built-in function that was kind of like revert or require, that essentially you could like put the condition, well, on transfers, you could put like the condition, the effects, and the transfer them. Essentially would transform that call into something like, well, the whole condition effects transfer pattern. So essentially you would solve this one, well, this one kind, which is like the most important according to me, well, I think so, type of reentrancy attacks. But the thing with that is that kind of like violates the idea that functions have their parameters evaluated before being called, and essentially does away with the idea that SafeSol is a drop-in replacement, because at that point I'm actually adding new things to Solidity and asking programmers to make changes to their contracts and all that. So right now it's not part of SafeSol, but if someone has some idea on how I could at least solve partially reentrancy using some trade-offs, please come to talk to me later. I would really appreciate it. Been thinking on it a lot and no idea how to maintain that without breaking the drop-in nature of it, but well. Now, bar resolution. So, yeah, essentially people write contracts and they define their variables using the bar keyword, and Solidity resolves that to some type, like the most famous one is like, in for loops it's usually resolved to uint8, which is quite small. So you have like the case that an attacker might be able to actually overflow it. If you have SafeSol or well, SafeMath, something like that, that essentially breaks your contract. So essentially, because using bigger types doesn't really incur a much higher cost, essentially we resolve the bar keyword and we make like all types like big, essentially. So that typical issue that is like people just writing bar and not being resolved to uint8 or some really small type is fixed with that. And that links with the next stuff, which is essentially, yeah. So people don't think much about, hey, what's going to happen if I get like a ton of uses of, if like people start creating a ton of uses or a ton of like, or this variable that loops over an array may, well, at some point the array grows larger than 256 slots or something like that, and they don't think properly about it, and they just like create, well, use the types that are like smaller for the use case, and that usually leads to like a ton of errors down the road because, well, yeah, you have issues like using SafeMath and all that stuff. So the easy fix is to just don't think about the cost, because using types, well, bigger types is not that much more costly, and actually at some, it may be that it's not more costly at all because of the way that, well, storage is packed inside the EVM and stuff. So at some point you don't even get any gas advantage. But yeah, that's like an easy fix for not that much cost. And now, this is I think this is like a huge issue with Solidity. And the thing is, nobody expects this. And well, the issue is that people, well, in every other language under the sun, when you define a variable inside a function, which would be called a local variable, the variable is local, right? It doesn't alter some other global variable or something like that. And the thing is, in Solidity, if inside a function you define an array, struct, or a mapping, and you don't add like a memory or storage modifier, Solidity actually automatically makes it a storage modifier, and that leads to it pointing to the first slot in storage inside Solidity. And what that means is that essentially if you're writing to the variable, you're overwriting some variables that you have stored, so global variables probably. So that's a huge issue because, you know, people come from other languages, they're used to local variables being local, they come to Solidity and boom, local variables are not local anymore. And they're just like writing to some variable, they think that it's just for that function, and they're actually overwriting something else. And yeah, it's a huge issue for people starting with Solidity. So the easy fix for that is just like always specified memory or storage, and yeah, that's pretty much it. So yeah, actually currently the SafeSol is working. It's released, you can check it out on that page. It's also on NPM as SafeSol. Well, it's MIT licensed, and currently it has not been formally verified. So if you want to use it, even if, well, it works, but use at your own risk, I wouldn't recommend using it right now because it hasn't been tested. There's probably like some subtle bugs that I haven't found out, but yeah, you're free to like go explore, look at the code, try to run it, see what you get, and yeah, all that. So yeah, thanks everyone. Is there? Oh. Any questions? Okay. Oh.
Hey, thanks for the presentation. Is it a fork of Solidity 0.4? And if so, have you migrated to 0.5?
Currently, well, it started as a fork. I've like contributed some PRs to Solidity, so I know a bit my way around the code base. And I started like using a fork of Solidity, but the thing is, I'm not working on it full time, so keeping up with the whole, well, with the stream of commits every day, every hour into Solidity was just like not viable for me to like keep the fork and like solve all whatever merge conflicts appeared and all that. That was almost like a part-time job or something like that, and I couldn't keep up with it. So I migrated from that to an approach that essentially takes the AST code, well, the AST tree from like Solidity source code, operates on that, and then like transforms it back into Solidity, and then that's compiled with Solidity. So essentially, what SafeSol is like a transpiler from Solidity to Solidity. Yeah, so, yeah, well.
And are you planning to propose these changes to core Solidity language, maybe with a -- safe option?
Yeah, essentially the idea would be to eventually get them merged into Solidity. That would be pretty awesome, but as I said, some of these changes, they're not well suited for being in Solidity, but yeah, that's been like something in my mind. Like actually, at some point, being able to send a PR and, well, make it into Solidity, because that would, I mean, it would make the whole process for new users really easy. Yeah, so eventually, well, currently my plan is to keep on developing SafeSol, and when I feel it's mature enough and I've received like a ton of feedback from people using it and all that, and I know which features are actually helping, which are not, and probably add a ton more, the idea is, yeah, to send it, like, move it upstream into Solidity. That would be awesome.